So let's talk about the intercept form of a straight line, the intercept form of straight line. And this is where we use the intercepts, the x and y intercepts of a straight line to write its equation. So let me draw a straight line right away. Let's make it like this. I think it should have been the other way around. Let me just do it the other way. Right. That. Now, I'll write out the intercepts real quick. Let's say this is the y coordinate system. This is the x coordinates. Let's say that the intercept on the y coordinate is b, and the straight line looks something like this. And let's say the intercept on the x coordinate is a. Now we want to write the equation. So there are a bunch of ways we can approach this. The first one, let's just use the simple slope-intercept formula. So let's use y equals mx plus c. From here, what we do is we figure out what m is. So the slope m is equal to the change in y over the change in x. Let's figure out 2 points. So let's just take these 2 points right here. So this point is 0 comma b, and this one is a comma 0. The change in y is 0 minus b, and the change in x is a minus 0. So that's equal to minus b by a. What's c? Well, c is the y-intercept, in this case it's b. Now we put all of this back into this equation, so this gives us y equals negative b upon a x plus b. We can divide all of this equation, the entire equation, by b. That gives us y upon b equals minus x upon a plus 1. This implies x upon a plus y upon b, plus y upon b equals 1. So that's one way to figure this equation out. Let's try another one. The other way we can do this is, let's just suppose any arbitrary point that lies between these two intercepts. Let's say that this point is h comma k. Now h comma k, let's join h comma k to the origin, so you get this, and now you have two triangles, right? Let's name this point as p. Let's also draw perpendiculars in these two triangles, so perpendiculars from p to both of the coordinate axes. Now what we can say is, let's say this is point b and this is point a, this is point a. So we can say that the area of the triangle AOB is equal to the area of the triangle AOP plus area of the triangle POB. Now the first one, this is just equal to half times a into b. This area is equal to so AOP. So this length, the perpendicular, the height is equal to k, and this is equal to a. So half into a into k, plus this length is equal to h, and this length is equal to b. So half into b into h. You cancel all the halves, and that leaves you with BH plus AK equals AB. Now you divide this entire equation by AB. So this gives you H upon A plus K upon B equals 1. Now, H and K can stand for any point. So in like typical locus fashion, the equation of the straight line is x over A plus y over B equals 1. So that's another method. Let's look at one really quickly that's based on the similarity of two triangles. So let's take these two triangles. We will name two more points. Let's say that this point is A dash and this point is B dash. Now we will look at these two triangles. We will look at B dash P. And the other triangle we look at is PA-A. Now, in these two triangles, obviously these are similar since you have two right angles. You take this angle to be theta, so this angle is going to be 90 minus theta. So this angle, since this angle is theta, this is again just imitating the x and y coordinate system. So this angle is going to be theta. Now these two are similar triangles. So that means that the ratio of their sides is equal. So a dash p over a dash a is equal to b dash b, the vertical one, over the horizontal b dash b. So a dash b, let me use a different color. So a dash p is equal to this distance. A dash b is equal to k. So k over a dash a from here to here. So this entire thing is a and this thing is h. So whatever is left over is a minus h. So k divided by a minus h is equal to b dash b. So this entire part is b. This thing is k again. So this thing, whatever is left over, is b minus k. B minus k divided by b dash p. So this thing, this length is it's h. So we'll write h here. So now we cross multiply. When we cross multiply, we get k times h equals a minus h times b minus k. This leaves us with kh equals ab minus bh minus ka plus hk. The hk's get cancelled out, so this gives us ka plus bh equals ab. Now, since this holds true for all such points lying on the line, we replace h by x and we replace k by y. This leaves us with bx plus ay equals ab, or x upon a plus y upon b equals 1. So there, the third way to figure out this equation. In totality, the only thing that you need to take away from this video is that the equation of a straight line that, let's say, passes through, I don't know, let's take the points 0, -1 and -2, 0. It's the x-intercept is -2 and the y-intercept is -1. And this is equal to 1. So there.